Welcome to Fire University. This is a podcast dedicated to fire ecology and management within the Natural Resource University Podcast Network. My name is Dr. Marcus Lashley. I'm a wildlife biologist, an assistant professor of disturbance ecology at the University of Florida, and a lifelong hunter that's passionate about wildlife conservation and management. In this podcast, I will interview scientists and professionals not only on the latest research in fire ecology, but also about their experiences, in hopes that you as the listeners can learn why fire ecology is important and also how you can use it to meet your natural resource management goals. So let's get to the burning questions in Fire University. Hey everybody, welcome back to Fire University. Today, I have an old lab member back to talk about a study that I think is really exciting. We've just gotten it published, and I've gotten quite a few questions about this. So today I have Moriah Boggess here, and he's currently the state deer project leader for North Carolina. So thanks for coming on the show, Moriah.
I'm excited to be here.
Yeah, I'm excited to have you here. I think the story behind some of your master's research with me is really interesting, since you did come to work on fire and deer with me, and then we ended up getting a string of something like 700 burn days in a row that we couldn't burn on, or something, or 700 days in a row that are no burn days. I don't know, something ridiculous. But you brought the rain with you when you came, so we ended up coming up with some pretty cool projects that you worked on, and now we get to talk about this one you've just gotten published, about how fire or exposure to fire affects wildlife preference for acorns. So can you tell us a little bit about that study, and why do we even care about that? Just what did you do and why do we care?
Yeah, so boy, we did a lot of stuff. I think touching back on what you brought up there, the burn days. One interesting part of this project was the treatment for our burned acorns. We couldn't even do that out in the forest. It was that wet even in February and March in Mississippi, which is the time you should start getting
Mm,
burn days. To be able to burn acorns, I actually had to collect leaf litter and then dry it indoors just to get the moisture out of it long enough, because it was raining outside, and then I
yeah,
eventually acclimated it to the ambient temperature and moisture, and we burned. Um,
yeah.
yeah, we had pretty much every wrench thrown at us, but we still made it happen. So
Yeah. Well, something interesting about that, it may have already struck some of the listeners, because I know based on feedback that I get that there are plenty of them that don't even think about burning an oak stands. Like when you say a prescribed fire, we're just thinking about the piney woods or fields or whatever, and we don't really think about particularly our upland oak forests. I don't think a lot of people are thinking of that as being somewhere we would use
yeah, so
fire.
I mean, I think that's, well, of course, it's short-sighted and maybe a little bit more focused, or we're a little bit too focused on some forests over others. So, for instance, like Longleaf, the Longleaf pine forests, there's a lot of information out there and a lot of talk about burning in those forests. But what do you find in Longleaf pine forests? You find pockets of upland oaks, usually blackjack oak, bluejack oak, and turkey oak, which
Mhm.
are also fire-adapted species that you find growing on well-managed properties, interspersed within longleaf forests. So
Mhm.
the fire and oak connection is readily available if you just look for it, just past your pines.
Mhm.
Moving into the Appalachians, of course, the upland hardwood forests found there, and even the central hardwoods, um, would have normally received fire, and that's how those forests regenerated. That's why we have as many oaks as we do today. And I think that the biggest reason we don't connect fire with oaks is obviously we're not seeing a lot of fire in the oaks right now, and that hasn't really played out yet. We haven't seen a large decline, at least noticeably to our eyes, of oaks disappearing, just because they're such a
Mhm.
long-lived species. Um,
Yeah.
of course, once you get down on your hands and knees and start studying what's actually going on in the forest, it'll make your hair stand up thinking about what is regenerating and what isn't. And Spoiler
Yeah.
alert, it's not oaks, and
Yeah.
that's an
Well,
issue.
I think that is an issue, and it's something that I have worked on, and you've been involved with a lot of work related to this topic. And I don't think people understand that we have a lot of dominant oaks, like you said, they're overstory oaks, and these oak forests throughout the Appalachian and southern or central hardwoods regions. And we think of them being healthy and doing fine, but there's actually a bottleneck in regeneration, which has been identified now by many researchers. And I've been a part of a group that has done some work on that. And the prevailing hypothesis is that the bottleneck is at least in part a result of fire suppression. So I think that's a really important point. And you got to help, I think, in another study that we did at the same time that kind of highlighted this point, where we collected a bunch of leaves from all these different species and looked at the leaf traits, like how they were shaped and how they curled and dried and all this stuff, and found that a suite of our oaks in the upland hardwood system actually promote fire. They burn really well. So that's showing you traits that promote fire progressing through that system. So now that we've kind of highlighted that fire apparently has played an important role and probably still does in upland oak forest, what about burning in the fall?
Yeah, so that kind of creates a little bit of an issue for anyone who's trying to regenerate oak, at least at surface value, because we think, well, of course, the next generation of oak trees are those little acorns falling off of the tree in the fall. And there's been
Mm-hmm.
numerous research projects before ours who have identified that fire indeed does damage those seeds, being those acorns laying on the ground,
Mm-hmm.
and it drives down the germination rate of those acorns. And so, some of the takeaways of those projects, and of course, intuitively, is that maybe burning in the fall wouldn't be such a great idea if you're killing the seed of the trees that you're trying to promote. So it
Yeah.
kind of creates this little bit of a complex for a prescribed fire manager, of an upland forest, because you want to use fire. Fall is a great time to use fire, especially when you're in Mississippi and it seems like it rains every single day of the year. If you're only 2 days that are good come in October or November, are you just not going to burn those days because you
Well,
might kill some acorns?
yeah. You always also have the problem in the Southeastern Conference, at least, that your Saturdays are pretty much tied up either with deer hunting or football or both during that time. So that makes it a little more challenging. But yeah, I think another point to add to what you're saying is we just got through talking about how important fire is, even in our oak systems. And one of the ways that we can improve that is to add more fire, but we're limited by burn days. So one of the ways that we can expand the burn window is to start burning at other times of the year, like the fall. And it turns out some previous work has shown definitively that the majority of good burn days that we get, where fire could be, you could pull a permit safely and light a prescribed fire and do that, is in the fall, and that is the least utilized part of the window in the South in particular. So, there's a lot of opportunity, but just like you said, at face value, we like to think of things as being really clean, clear cut, dry. And of course, if you have a bunch of acorns fall on the ground and then you burn over them, we're going to kill some of those acorns, and we inherently think that's going to be bad for oak regeneration. But maybe not, right? It's kind of
Right.
assuming that the only effects that matter are direct effects of exposure.
Yeah.
So what are some other things that could happen?
Yeah. So this is honestly one of the funnest things about forest ecology is it's so multifaceted because a you're dealing with a plant community that has an overstory, midstory. You have saplings, you have the herbaceous community, and then you have all the
Hmm.
animals within it. So effects of a fire. What do we know happens? Well, you burn off all the duff, the leaf litter. So
Hmm.
that's one effect. That's of course the fuel that's burning. That's what's burning up those acorns. So there's an immediate reduction in the fluff on the forest floor, which can be cover for small rodents, such as mice. And then, of course, you burn up any herbaceous vegetation on the ground, or at least you top kill it, or at least wither it back. And so there's an immediate reduction in cover. And then, of course, there's nothing on the ground that could hide those acorns, and they're pretty much the only thing left after a real good prescribed fire. So those are other effects of this fire that we talked about at the beginning of this project, is that we know that fire affects acorns, but we also know that it has other effects on the system. And I just covered those, the reductions in fuel. Then the other big question mark is, well, what does it do to the predators of those acorns, those seed predators? And this is where it gets really interesting. It starts to make its own gravy, because if you think about it, what I just talked about, all that fuel we're burning affects the animals that would then eat acorns. And it affects some of
Yeah.
them positively and some negatively.
Yeah. Well, some of the things that were really exciting and interesting, I guess, to me when we embarked on this project, and I promise, folks, we'll get into some of the nitty gritty of the particular study that we want to. But there's so many fun things to talk about, and I think it's good background. So we've done my lab, you included, have done a lot of work to show that fire can really affect the behavior of a lot of things that eat acorns, like deer and turkeys and squirrels and everything. So we may have a strong attraction to those burned areas. That's pretty typical for most species. Uh, Another thing that was really interesting that you said, and it stimulated me to think through our conversations, particularly during your defense. And I'm curious if you remember these conversations, where it really is at face value. It seems like, okay, you directly kill a lot of acorns, expose a lot of them, right? And then they're visually very easy to see when they're laying around with no duft covering them. And do you remember our conversation related to that, as to whether or not they're actually more vulnerable?
I tried to block out my whole defense, you know. No, no,
Well, I
I mean,
used
there's,
an analogy with you, and I thought that it turned on the light bulb, but we'll see if you come back with it.
well,
This has been years ago, folks, by the way.
so on this subject, there's so much that comes to mind, because this is something I've mulled over since, and that is
Yeah.
the multiple effects of prescribed fire, right?
Hmm.
And this is just one of them. Is does it expose those acorns to more predation? Are they getting eaten more?
Yeah.
Um, if I had to guess, because I'm just going out on a limb here, anecdotally, I would say it probably increases deer consumption of those acorns, because they're probably
Yeah.
more easy to find. Um, but that's fully, I mean, it's not supported. I have no data to support that. So I don't remember the specifics of our conversation in my
Well,
defense.
I gave you the analogy of burnt toast.
Mm-hmm.
So, and I led in with that. And one of the things, we immediately see, okay, these acorns are laying around on the ground. Some of them are dead. But if I gave you a piece of toast that I have burnt to a crisp, are you going to eat it?
Now, see, I won't, but I know people who would.
Yeah. Well, it depends on how hungry you are, right?
Yeah.
Yeah. So the whole point, and that was the point during your defense, is that it may make them more vulnerable because they're visible, or, and it probably differs by species and even how hungry those species are, even. But it also may conceal them or make them less preferred because you've charred them and now they taste like ash, and some things may not like charred acorns. Or it may make them taste better because we cook our food, right?
Mm-hmm.
So now we've got cooked acorns. Those may be really good. But the other thing is, we know, at least for squirrels, if you have you ever planted an acorn in a pot trying to grow an oak tree?
Yeah, I sure
Think
have.
through that. Yeah, I know that some of the listeners have. I have done this countless times now. If you put an acorn in a pot and then put it outside where there are squirrels, what's going to happen to it?
It's probably going to get gone.
Yeah, the squirrel's going to get the acorn. At least that happens to me all the time. Maybe I just have smarter squirrels, but even if it's in a place like I could have pots sitting out there with soil in it that don't have any acorns in it for years, where we have multiple generations of squirrels turn over, and then I go put an acorn in it, and next week acorn's gonna be gone. They're gonna rob it, and that's always something that stuck into my head. And I actually did an experiment, so it was like a pseudo experiment during my PhD work along these lines, where I was actually going out and burying acorns in the yard where we could see them from our office, and it was kind of cool because squirrels were coming back and getting the acorns. So I'm thinking, are they watching us in the trees? But the reality is, when you go and look in the literature, they have this keen sense of smell, and they use that to rob caches from each other. So when I say
Yeah.
cache, I just mean a squirrel goes and buries an acorn. So all of that, I'm basically telling this elaborate story to say that the other thing that has happened when you burn these acorns is you have potentially concealed them from one of their main seed predators, squirrels, and seed cacher as well, uh, because you may make them smell like everything else. Everything smells burnt, or you may actually have the scent absorbed because there's so much charcoal around, and we put charcoal in things to absorb scent all the time, right? So there are lots. The whole point is there are all kinds of things going on in the system that are really cool, and because of that, we we have lots of things to research, but we also have to do things in particular ways to try to isolate the variables of interest. So now I think we're ready to go to your experiment, and we have that context. So what did you do in your experiment to try to isolate the variable of interest?
So we got started first with the acorns. Um, had to keep them in refrigeration, of course, until we burned them. Um,
What
had
kind of acorns was it?
Yeah, 8 species. So I had 4 upland species and 4 more bottomland species. So in the upland
Hmm.
category, we had black oak, scarlet oak, northern red oak, and southern red oak. And in the bottomland category, willow oak, Shumard oak, Nuttall oak, and cherry bark oak.
Mm.
I got those all collected. We
So pretty broad suite of species.
Yeah, pretty broad. Most of those, they're found across the southeast, and they can. This is one interesting thing. If you walk through the woods from a bottomland to an upland site, there's no nice clean line where one species disappears and another appears. I mean, there's exceptions to that. I mean, sometimes that happens, but
Hmm.
there's a wide gradient where those species occur from bottomland to upland. So there's a little bit of a blurry line there between those two categories. But we wanted to have species across just kind of across the range of fire adaptedness. So we chose those 8. And I mentioned this earlier. We had to collect a whole bunch of leaf litter. Picture, I think it was 4 or 5 55-gallon trash bags I collected of leaf litter. We took it back to an old lab building there at Mississippi State that no one was using, and
Well,
it was a concrete floor, and I just dumped it all out. See, there's this room that looked like the
well,
forest on the
yeah.
inside.
Well, a lot of folks are just thinking about raking up leaf litter. I'm guessing in the yard or something. It's like, oh well, that's not that many bags. You can do that in a few hours. But what else did you have to do
Well,
with
first
that
I had to
litter?
get it. Yeah, I had to first identify a stand where I could get it. Um, I had to collect it out of the woods, so it wasn't just like off of a clean lawn.
Yeah.
Once we got it back in the lab, we had to control the temperature enough because it wasn't a used building. We had to control it at least enough that it could dry out. Then I had to get it all collected back into the bags to take out in the field, and I did clean up my mess behind me. So that was also another job is cleaning up that room because it, believe it
Yeah.
or not, wasn't made for drying out leaf litter. We took
No.
all this out into the field and we burned it um, over 5 different fire plots. So we set out acorns and marked them by species, shook them down just into the top of the leaf litter so that they would be
Yeah.
in the leaf litter strata, approximately the location they would be in fall when a prescribed fire would occur. And then burned it. Pretty much as simple as that. And
Yeah.
then picked up the
I
acorns.
think you even had to calculate how much leaf litter was falling approximately, right? And then
Yep.
you
Yep.
basically had to weigh the leaf litter and recreate how much would fall out of the trees onto the ground and where would the acorns be relative to that biomass? That's really, I guess, kind of giving people a peek in, the folks that wonder. I know that plenty do because they ask me what I do all the time. Wonder what's going on behind the scenes in some of this research. We're trying to pay attention to these little details like that. That could make a big difference, right? If you put a giant pile of leaves there, that's probably going to have a bigger effect on the acorns than the amount that's falling out of the tree. Likewise, if you don't put enough to carry the fire across, that's going to have a different effect on the acorn. So we were trying to simulate, I guess, what I'm saying, simulate what is happening in nature.
Yeah, yeah, that's a good point. We had to measure the leaf litter. Then we also put out fire pyrometers. They're basically just pieces of metal with tape that, or sorry, with paint that melts at different temperatures to
Hmm.
monitor the fire temperature across those plots and even the residence
Yeah.
time to make sure that our fires weren't substantially hotter or or they weren't too weak to not get a treatment effect on the acorn. So there was a lot of
Hmm.
care that went into it to make
Yeah.
sure that because of all of the because basically taking that leaf litter indoors was taking it out of its environment. Suddenly we're
Hmm.
not in the natural system. Then we had to measure all these other factors to make sure that when we put it back
Yeah.
out, that that we were using a fire that was representative of what a
Yeah.
manager would use.
Well, and uh, I think this is a good place to talk about this. Is one of one of the points of an experiment is to take things out of the natural environment so that you can control confounding issues. So we've just talked about all these different things that could happen, right, in a forest ecosystem. If we just went out and burned an area and then followed acorns, there would be all kinds of things going on that we're observing, and we don't really know what is responsible for what. But in your scenario, you did it in that specific way because you wanted to isolate the effect of the acorn being exposed to fire on wildlife preference without all the confounding issues that are changing the fact that changing all the vegetation structure and everything affects the behavior of the animals. We wanted to get rid of all that variation. So when you talk about, I hear it talked about from both ways. The experiment is not a natural system. Well, it's by design not, for some specific reasons, and that's not a problem. It's in many cases a strength. We want to mimic the things that are variables of interest with nature, and then isolate those from other factors that are not of interest, which is where the I guess the mesocosm, isolation part of it comes in. So it's
Yeah,
an important point, I think, for people.
yeah, it's a good point because we could have taken one stand, thrown out acorns in there, watched them, taken another one, burned it, put out acorns before the burn, and then monitor what happened to those acorns. But all we would know essentially is what happened to acorns in those two spots. We wouldn't know if it was a change in because of the change in the litter on the ground from the fire, if
Yeah.
it was the plant community, if it was that maybe there was just a bunch of squirrels that liked this particular block over the other one, and that's
Hmm.
why there were squirrels all over one and not the other. There would be
Yeah.
so many of those factors that we would just have
Yeah.
to guess, and that's not what science is. We need to measure.
Right. Well, and so what were you specifically trying to measure?
Yeah, so I should describe that exactly what my question is, or it was. Question was, when acorns are exposed to fire, does that change the rate at which they're removed by predators? And we took that question a step further by asking it in the context of predators who cache and predators who do not cache. So just to explain that a little bit, a predator who does not cache, a white-tailed deer is a great example. When a deer comes across an acorn, it's not picking it up to go bury it somewhere. The deer's eating that acorn. That acorn doesn't have a chance of surviving any longer because it's now dead. It's in the gut of that
Hmm.
deer. If a gray squirrel, for instance, comes and picks up that acorn and runs off with it, he may bury that acorn. He would cache that acorn to be consumed later. Now, squirrels and other cachers like chipmunks and mice, they do consume most of the acorns they cache, but there is some percentage of those acorns that survive. that the animal never goes back to eat later. So in spring, that acorn would germinate, and there's actually quite a bit of data out there to support the statement that being removed from the top of the leaf litter and being cached actually improves an acorn's chance of successfully producing a seedling because it's now
Hmm.
in the soil, exposed to moisture. And as long as that rodent doesn't come back and eat it, um, or another one find it, like you pointed out, then
Yeah.
we're good to go, and that tree's going to grow. So we wanted to split our question up and look at it a couple different ways, ultimately to get to satisfy our curiosity of, well, does burning change the rate at which these acorns are removed and therefore improve or decrease the chance of that acorn being able to produce a seedling in the future
Hmm.
when it's burned or not burned?
Yeah. And just to highlight some of this, because it's such a complex issue, and I'm thinking through what are the things I would wonder about based on what you just said. The like a squirrel, we'll just say regular old gray squirrel. You said that they actually eat the majority of acorns they've come in contact with, right? So they are caching a lot of acorns, but they're eating a lot of those. They're not store. They're just storing them for later, essentially, and they come back to a lot of them. Not all of them, but also some of them get stolen by other squirrels or other rodents, uh, and some of them go bad or whatever. And even with all of that, it's still beneficial from the oak's perspective to sacrifice a lot of the seeds so that a few of them get cached and forgotten, because those few that get cached and forgotten perform so disproportionately much better that it overwhelms from a fitness standpoint and long-term fitness of a population. It overwhelms all of those other negative effects, which is sort of like what we were talking about with the burning, being exposed, the acorns being exposed to fire. That kills a lot of acorns. But if it changes what happens to all the ones that didn't in a particularly favorable way, that might actually still be a net gain for the oak. And here's an example how that could happen, just for the listeners. It's not related to Moriah's study, but it was one of the reasons we did the study that way. There were some other studies that have demonstrated very well that if you burn in the fall and an acorn then gets cached in that burned area, that seed performs way better than a seed that gets cached in an unburned area. The analogous scenario where it hasn't been burned, the seed that gets cached there does not perform as well. So some research has shown that because of the changes in the nutrients and competition and light conditions and all those different things in that burned area, the seed getting cached in it actually fares very well if it doesn't get killed by exposure. So that's sort of the opposite of what you did, though.
Yeah. Yeah, I mean, oaks, they just play the numbers game. If in a good
Yeah.
mast year, they're producing one tree's producing 3 to 5,000 seeds. They just need one or two of those to survive to be successful. Really, just one to be
Yeah.
successful. So it's purely a
Yeah.
numbers game, and it's about producing a quality seedling that will survive.
Yeah. That's a good point. So you all right, you've gone to uh, the part of the study where you collected these acorns, you put them in a plot, and you burned them, exposed them to fire. So now what did you do?
So next thing, we were working in two different study sites. They're about 30 miles apart. And across those two different study sites, we selected 20 locations for plots um, in upland hardwood forests. And half those plots were randomly assigned burned acorns, and the other plots received unburned acorns. Each one of these plots consisted of 9 trays, and these were circular disc trays, about 8 inches across. And in the bottom of each tray, we placed sand so that it wasn't just a plastic bottom. So now picture a grid array of 9 circular trays filled with sand, so 3 across and 3 down. They were placed each about 6 inches apart in this grid, and then they were all placed out on the hardwood leaf litter, And above the plots, up in a tree, was placed a trail camera overlooking these trays.
Yeah.
And if you remember earlier, I said we had 8 species of oaks, and for each plot, whether these were going to be burned acorns or unburned acorns, all species were added to the plot. So one tray would be for one species, one tray for another. So out of those 9, you had 8 with acorns in them, and then there was one tray that was left empty because we didn't have a 9th species.
Mm-hmm.
And so of course we randomly assigned the location of each species in each plot so that there wouldn't be any selection based on being on the edge or being in the center of the plot.
Mm-hmm.
So each plot was set up a little bit differently. And then that camera was placed way up in the air, around 10 feet up in the air, looking down so that we could observe whatever came to remove acorns. Those cameras triggered when an animal came, and then we had it set on video so that we could count the acorns as they were removed, watch animals remove them. And then we also had that camera set to trigger every hour so that we could take a census of the acorns and just make sure that none had been removed without a trigger from the camera, which actually did happen. More than likely from smaller predators that don't always trigger a camera consistently. So then we observed the plots for up to 20 days, and then we had a whole bunch of data to go through. And that was simply
Yeah.
just sit down at a computer and for each plot go through and count acorns endlessly as they were removed by plots, recording times, what removed
Yeah.
them, getting all that data recorded
Yeah.
all across all 20 plots. And
The not so fun part,
yeah,
data
yeah.
process.
Well, it was actually pretty cool what all came to the plots, and yeah, we had a
Yeah.
bobcat come and visit, several turkeys, some deer. We had a gray fox come and eat acorns and take those away, and so there were some surprising things.
Mm-hmm.
They were
I
really
remember
fun.
that you had some videos of a little vole that was like rooting around under the leaf litter and come up and grab acorns off of some of the trays. So,
Yeah, he would just pop up. He would just pop up out of the
yeah.
leaf litter, grab an acorn, and shoot down underneath it, and then he would just disappear. Which
Yeah.
again,
It's funny.
it's cool because you spend a lot of time in the woods, you don't see all this stuff. But when
Yeah.
got a
Not
camera
like
looking
I
at the
said
ground,
I mean, how often do you sit in the fall in an oak stand and, just observing nature? And there's still stuff that we were seeing on that camera that I don't see. I do that all the time in the
yeah,
fall. I know you do. And
yeah,
a lot of those things I've just never seen. It was pretty cool. It's a really cool study design too. Clever way to use cameras. Obviously, that was somewhat artificial because you had the acorns on trays, but that allowed us to see them easier. Also, one I don't remember if you said it or not, but another element that was intentionally uh, a little bit different than would have been in nature as you put all of them in unburned forest because we were trying to control for the effects of all the things going on with the fire in nature. We're trying to control for all those confounding effects. So
right, yeah. So you bring that up, the plot specifically being unnatural. That was by design. We wanted each acorn, whether it was burned or unburned,
mhm,
to have the same odds or same chance of being detected by a predator, a seed predator. And then we also
mhm,
wanted, yeah, those being in unburned forests, we wanted that to be consistent across treatments. Again, we're trying to get this project as far removed from all the other effects of fire, like the burning of the leaf litter and the understory, that can change animal use of a stand, and solely
mhm.
focus on what's happening to an acorn, chemically, physically, that changes whether an animal wants to eat it or not.
Yeah, yeah. I think that's a really important aspect of the study. And for those of you that are wondering, what does this actually look like? We're going to put a couple of videos online showing you the design and showing you animals actually coming in and recovering acorns from these different things. So we'll put that online. Also, we'll have some links to the papers, some of these papers we've discussed. If you're interested in some heavy scientific reading, happy to provide those. But okay, well, let's quit beating around the bush. What happened? Like, what are some take home points when you exposed all these acres to fire, at least half of them, and then you've observed how it affected selection by the community of things that eat acorns? What actually happened?
So at the end of the day, the burned acorns on average took longer to be consumed than the unburned acorns. So
Okay.
that is, by the end of the study, so we had a very limited amount of acorns, about 1,800 acorns in this project. By the end of it, they were pretty much all removed. However, we looked at the amount of time it took for each acorn to be removed. So you had basically a
Hmm.
probability of removal that increased over time, and the slope of that increase was much slower for burned acorns, so that
Yeah.
they would survive longer in these plots.
When an important aspect of that may not be immediately obvious is that's kind of the strategy of oaks, right? They synchronize their mass production. People have probably heard that before. They're mass seeding. That's what that means. So they're going all in all together at once, producing a whole bunch of mast to slow down the removal of acorns. This is thought to just satiate the predators, right? So that's sort of what you're saying that fire helped do, right? It slowed down the removal of acorns.
Right. Yeah, because so these were all red oak species, and
Yeah.
there's no certain time when animals just say, "Oh, hey, I'm done eating these acorns," and
Hmm.
gonna let them sit till spring and they germinate. They're always just kind of playing the odds of surviving long enough to be able to grow into a tree. So while the acorns in our project were removed by the end of it by a seed predator, what's important is that it took longer, because the longer it takes for those acorns to be removed, the more likely that when there's a mast year, which is exactly what you were saying,
Yeah.
Marcus, it's more likely that there will be survivors for that spring
Yeah.
germination.
Yeah. So that's one important thing, but just like we said, it's more complex than that. If we also look at different predators in the community, they responded quite differently, right, to being burned.
Right. Yeah. So there was, of course, remember we had these classifications, cachers and
Hmm.
non-cachers, and I'm just going to walk through these species real quick. I already broke it
Yeah.
down with some examples. For non-cachers, our two main non-cachers were deer and raccoons.
Hmm.
Now, there were a couple others that were poorly represented, like wild turkey, the gray fox I mentioned, opossums, that only took
Wait,
a few
don't say
acorns.
that don't say they were poorly represented. They just weren't detected very much. It's hard for
Okay.
me to admit that a turkey in any circumstance is poorly represented.
Well, I went through the
I'm
videos
just
and I
kidding
would
with you.
say they were poorly represented.
Yeah, they
um,
just weren't detected very much.
yeah,
Most
yeah.
of our pictures were not turkeys.
There we go. We can
But
safely say that. And that was the
yeah,
non-cachers. In the cacher category, there was a lot of gray squirrels, southern flying squirrels, fox squirrels, and then a couple different mice and vole species.
yeah,
And so that pretty much breaks down those two different categories. But importantly,
yeah,
if we look at them as either a cacher or non-cacher, burned acorns had a higher probability of being eaten by the non-cachers than the cachers. So in
hmm,
other words, once they were burned, it was more likely that those non-cachers like deer and raccoons specifically did a lot of this, would seek out those burned acorns.
yeah,
And and we talked about this before. Interestingly enough, if we look at deer consumption of acorns, almost every single acorn that was eaten by a deer in this project it was a deer eating a burned acorn, with the exception of
yeah,
just a handful.
yeah. That it was overwhelmingly like of all the stuff in the 1,800 acres or whatever you put out, 900 of them are burned, 900 are not, roughly. I forget what the actual numbers are, but something like that. And only a few were eaten of the unburned category when deer had access to both. They were. So, what about the one thing you didn't say? Was there any preference for the species of acorn? Like, did you see any Like, was there a preference among the different red oak species, or did the fire shift that at all?
So the shift in survival time, or I guess the reduction in removal rate when acorns were burned versus unburned was pretty uniform across all the different species. And I looked at
Yeah,
this, several different ways. Looked at it sideways, looked at it
man.
front ways, back ways, and there
Yeah,
there wasn't a lot of
I remember
hard data there.
squinting.
Yeah,
I remember squinting. I was like, wait a minute. There's
yeah,
not any selection between these species. Yeah, for red oaks across these 8 species at least. That's what I remember as well. Is thinking, wow, they really just were eating all of them.
yeah.
There didn't seem to be a preference for any of the wildlife species for any of the acorns species. Yeah, that was
Incredibly,
striking.
incredibly too. To that point, you think about northern red oaks to willow oaks. There's a huge difference in the size of those acorns.
Hmm.
Um, you think about an oak like scarlet oak or southern red oak compared to to Nuttall oak or Shumard oak, they have very different adaptations to fire. So we had a wide range of oak species here, and yeah, at the bottom line was for all of these, they were less likely to be consumed when they were burned. And then if we trying to get at selection, there was simply wasn't enough data to get at selection by certain seed predator species to
Hmm.
get at selection of different acorn species.
Yeah. Well, to kind of, I guess, think about that a different way, where so you said that deer and maybe another species really liked burned acorns. Were there any that avoided the burned ones and only ate the unburned,
There was one.
or were you know really
Yeah,
who's the
yeah.
culprit?
The culprit is those pesky old fox squirrels. So
Fox squirrels.
interesting. Yeah. The interesting thing here is that in our sites we had both gray squirrels and fox squirrels that would show up. So there wasn't any
Hmm.
real difference between site characteristics because both species were showing up there across the
Yeah.
sites. However, the gray squirrels, they ate burned and unburned acorns. In fact, gray squirrels kind of seem to favor the unburned if we just look at the totals. But when you look at
Hmm.
fox squirrels, they did not eat one burned acorn. They just, I guess they
Isn't that
avoided
something?
them.
And when
Yeah,
I think of if we were going to break the squirrels into fire squirrels or not fire squirrels, I would think of the fox squirrels being a fire squirrel.
yeah.
They are prevalent across a lot of our open pine systems that burn all the time, and they didn't eat any of the charred acorns. That's pretty wild.
And again, the southern flying squirrels, they only ate burned acorns. So,
Yeah.
again, the squirrels they were a very mixed bag. And the interesting thing, when we talk about this, we're talking about net positive or net positive or negative effects to acorn
Hmm.
survival by looking at these different predators eating these acorns. And it's obvious, at least from this data on these study sites, that these different species, at least these certain species, had some selection for burned or unburned acorns.
Yeah.
Of course, the presence of those species, or at least the population density of those species, is going to vary by site. I mean, it may even
Hmm.
vary within site depending on how large the property is. So it's very obvious that if there are negative effects of let's say deer selecting to eat these burned acorns on this site, if you're in an area with a lower deer population, that's not going to be as much of a factor. And it may be the other
Hmm.
side where your unburned acorns are just getting hammered by the fox squirrels. But on a
Yeah.
particular site, if you burn there's no gray squirrels to be eating those acorns. They're suddenly surviving
Hmm.
longer. So I guess what I'm getting at
Yeah.
is there's probably a very mixed bag of effects depending on the suite of species using that stand before and after fire.
Yeah. That's a good point. Another thing is we're all everything has been from the perspective of the oak. We're presenting it as good or bad based on that perspective. But the alternative to that is if you're a deer hunter and you burn a stand in the fall and there's a bunch of burnt acorns around, deer are gonna get in there and eat those acorns, right?
And raccoons and gray squirrels.
Yeah.
Yeah.
Well, I mean, there you go. The mixed bag of game right there.
Yeah. But if you're a fox squirrel hunter, you might be need
Yeah.
to hunt next door.
Yeah. That's so crazy. Well, I think this was a really cool study and fun to talk about, and it lets us highlight burning in a system that it's not typically thought of, at least for most of our listeners, I think. So that's fun, and I think uh, it's a really cool, really fun way to study how all these things work. Hopefully, people will get some real value out of the information, even if it's just to understand that things are really complex. Do you have any take home messages that people can take from this?
Yeah. We mentioned this before earlier. So we have been talking about whether it's good or bad at the acorn level. But, at the end of the day, the distribution of, let's just say, fox squirrels. I don't know about anyone else out there, but if you sat on different deer stands, you've noticed in this one spot there's squirrels everywhere. In this other one, there's just not as many squirrels. Likewise with deer, if you really put in your homework, you can find where there's concentrations of deer using different parts of your property. My point with this is even the use of these different species is a patchwork across a property,
Yeah.
especially if the property is managed well. And you could burn, you could burn 100 acres, and the effects for the acorns underneath different trees across that site is probably going to vary from tree to tree, or at least, every couple acres to every couple acres,
Hmm.
because the the predator species that would eat those acorns, the sweetest species there, and the amount of them is going to be different for every tree. So at the end of the day, getting fire on the ground promotes heterogeneity. It's
Hmm.
it's bringing out those effects that those predators have by either making them select more or select less those acorns. So I would say, bottom line, if you're concerned that this, in this project we primarily detected deer eating the burned acorns, don't let that deter you from burning, because what you're
If you want to
doing,
regenerate out.
right, what
But
you're doing is promoting heterogeneity.
yeah,
Heterogeneity. That's
but
my
if
takeaway from it.
well, and if you're a deer hunter and you want a deer to be more attracted to the acorns, then let that be a primer to get you setting more fire,
And maybe
especially during that fall.
pick your favorite oak stand that's producing really well one fall. You're going to sit anyway. Go ahead and burn it, and
Yeah,
sit
there you
tight
go.
and grab your gun.
Yeah. Well, that's good stuff. Well, Mariah, if people have follow-up questions, where can they find you?
um, I guess on Instagram at Moriah underscore biologist. I'll
Okay.
spell that because that's not intuitive. It's MORIAH underscore biologist.
All right.
You
Well,
follow up
and
with me there.
we'll link you and the UF Deer Lab and at Dr. Disturbance accounts on Instagram. So, yeah, if people have follow-up questions, I encourage you to reach out to Mariah. Is very knowledgeable, obviously, about this subject, and I would be more than happy to talk to you about it. But in the meantime, I hope everything's been going well for you, Mariah, in your new gig there in North Carolina. And it's sure been fun talking to you. I really appreciate you coming on the show.
Well, I appreciate any chance I get to talk to Dr. Disturbance. It's a, a chance well taken. So I enjoyed it. Thanks for having me on, Marcus. And it's always fun to revisit a topic like this.
Yeah. And thanks everybody out there for listening. We really enjoyed bringing you this show. Our university is part of the Natural Resource University podcast network funded by the Renewable Resources Extension Act. If you like what you heard today in this episode, please follow us on all the social media platforms at UF Deer Lab.